All right, guys, very welcome to our ODSC West Warm-Up event. We are super excited to have our next guest, that is Ketan Umare, creator of Flyte. We'll be discussing a lot around why reproducibility, type safety, and collaboration matter for data science workflows. We'll also be discussing a lot around MLOps. So feel free to have your questions for Ketan. And not only that, we have our big conference coming up from 16 to 18 November in San Francisco. This is a hybrid event, in person and virtual. So, guys, you can actually find the link in the post itself. I've mentioned the link so you can have a look at it. And today we will be also joined by our co-founder, Seamus McGowan. Let's, without any further ado, let's have our guests here. Hey, Ketan. Hey, Seamus.
Hi, Ravit.
Very
Hello.
welcome.
Hey, Ravit. And hey,
Hi,
Awesome.
Ketan.
Ketan. Great to see you guys.
Same here.
I was just letting folks know about the West Conference that is coming up. So, just a quick overview about the ODSC. Yes, we are doing this live stream, so feel free to have your questions. And also, Seamus has been kind and he has offered one free pass for the West Conference. So feel free to type in hashtag West and we will give away that pass through a raffle. So please do so. And also, about today's topic, as I mentioned, we'll be talking around why do reproducibility, type safety, and collaboration matter for data science workflows. Ketan will be telling us a lot around it, and definitely I would love to hear Seamus's input as well. So feel free to have those questions coming in, guys. But to start with, obviously, Ketan, we would love to know a little about you, about your background, about where you're coming from. So feel free to do so.
I guess everybody wants to know where you are coming from, but in this case, I guess I'm an engineer. I started my journey in India. I did my undergrad in India, and then in Mumbai with like you, Ravit. Like I guess from our conversation, I lived like very close to where you live right now. So
Very close.
and I actually started a company in India. That's where I got my first brush with machine learning. Believe it or not, we actually had a neural network in 2005, which did not work at all. We kind of said that neural network is crap. Let's not use this. And then weirdly, I was leading a team after a year or so in the company, which was trying to build a model based on behavioral detection of the cohorts and so on. And what I realized, I know nothing. I was I had zero understanding of what I was doing, and I was leading a team. I'm like, that's like imposter syndrome plus plus. And so I was like, no, I need to study more, and that's how I ended up at Georgia Tech in the US. Couple of years over there. Did not work specifically on machine learning. I did work on some parts of machine learning, like especially performance optimization. I worked on CUDA before CUDA was cool. Like
Nice.
this is like, yeah, like I did that. I was probably some of my code is in kublas. Who knows? Maybe they've deleted it. But we were my lab was working on making auto tuners.
So you're a
Things that
speed
were
demon. You know how to speed it up.
yes, exactly. That was my thing. And I actually realized after those 2 years that I don't want to do this anymore. I don't want to go and read
Pretty low
instruction
level.
manuals, yeah, and fix everything. But it was a lot of fun. From there, I came on to Amazon, was there for 6 years, worked in lots of vSphere products, like starting from Fresh, logistics, like the predecessors of Lyft and Uber and so on, right? And then it was a small team at that point. This is like 2008, 9, and then at around I moved into mapping, and I started. There was like I actually moved into this completely hidden secret team at Amazon at that point in 2012.
Wow.
And I was like, "Whoa, what is this?" And the secret enticed me, and I got in. And then I got in and I actually opened they gave me the phone. and this was the phone team, the Fire phone team. I was like, oh my god, I want to way out. No, but just a joke aside, it was a crazy, crazy effort, and probably before its time that Amazon was trying to build. But in that specific project I was working, I actually led the development of maps for Amazon, and then from there, I became my love for mapping.
Wow.
I also did cloud. Like I worked on some AWS services and Oracle Bare Metal Cloud. First few people who started Oracle Bare Metal Cloud, and but that love for mapping came calling with when Lyft came back, and that's how I came back to Lyft. Led a team at Lyft that was doing ETA models. That's how machine learning came back in my life with mapping. And because of all the infrastructure background, I was like, there must be many tools. That's all problems that we were trying to solve. That's what led to us searching things around first, trying to retrofit many things, trying to break many things, modify, and then eventually giving up on that. What led to the birth of Flyte at Lyft, and this was circa 2017, mid 2017 or something. It was not even called Flyte then. And then over a period, as we got a lot of stuff, we kind of open sourced in 2020. And now, earlier this year, I started a company, Union.ai. I departed from Lyft, and I started a company, Union.ai, that's solely focused on Flyte and
Awesome.
things beyond. I know it was a long answer, but hopefully that gave you where I came from.
Very detailed.
That's an interesting journey too, because when was it, like 2013, when containers, Docker was a big deal. Maybe I got my year wrong there, but Kubernetes is actually okay. It's old in data science terms, but Kubernetes really only took off in 2016. It came out in 2015, right? So your experience kind of overlaps pretty nicely with that, and so I think you were pretty much at the forefront of this revolution in data engineering for sure. So yeah, very cool.
Oh, absolutely. We took a bet on Kubernetes too early, and probably was too early. We paid the price, and so
you learned some important lessons. And
lots of them. We know when it failed in all various scenarios. Like
because everyone thought Docker was the solution, and then you understand, okay, Docker's great for my laptop and my workstation. Now I need Kubernetes for on the cloud, and everyone thought that was the solution. Like, okay, but Kubernetes is not going to handle any workflow for me, so now I need something else, and here we are.
And not only workflows, like it was designed for services. It's actually like stateless services that run for a long period of time, and those kind of those constraints changed the design of the system, and we started fighting that design. Right, that's literally what we're doing with data science and machine learning. So we will get into this if we at some point. But that's
definitely.
You're right. We were pretty early with Kubernetes, and we've been sticking with it.
Always good to be early. It's good to be early.
Yeah, that's a super interesting journey, Ketan.
Thank you.
Very true. And that's amazing journey. And also you actually spent like 4 years at Lyft. So Ketan, how, obviously this is a very curious question, and it's a hot topic right now as well, the data engineering versus data scientist. But want to know your thoughts. Can you tell us a little about the role of data engineer and data science at Lyft? How would you differentiate, and not differentiate, but how does it kind of combine together?
I will definitely preface this with saying that all these opinions are my own. I no longer work at Lyft. I had a fun journey at Lyft, but I don't work there anymore. So please don't take this out of context. But when I started at Lyft, it was 100 odd engineers, so a small team, and I don't think we had any data engineers. Probably 2 people in the data platform or something, and so, but the company needed machine learning models. We had a lot more data scientists than data engineers at that point.
Oh,
wow. Interestingly, I think the reason why, or the difference between, let's say, Lyft and a taxi company is the machine learning. That's really the difference. It is a platform that's connecting things, and it has to do that efficiently. and well.
Right.
And machine learning really aids there. And when I say machine learning, I'm using a broad topic here. It could be operational models, it could, like OR science models, and so on, right? Economics models. So yeah, we had a biggish team of, when I say big again, it's not that big. Like 100 was the engineering strength, so it's not going to be huge, but still bigger than the data engineering team.
Yeah.
And then over the period, we had to solve our own problems. My team was actually just like, we were building an ETA model. And let me explain what ETA is. ETA is essentially when you open up the phone, you see a number. It says that's how much time it's going to take for a car to arrive to pick you up. Extremely crucial, because you get that number wrong, you lose trust with the audience. You get that number wrong, people switch. And once they switch, it's hard to come back, because even if the other thing shows them the bad number, they're not going to switch again. They're like, all right, both are broken. Another thing that it does is it actually predicts the time to the destination, which is very critical in calculating the cost of a ride. So we wanted to do this. We had to do machine learning. We had data, lots of data. We had to, get going with it, and lots of data in various forms, because we were actually getting raw GPS signals and so on. And we wanted to use all of that information to actually convert to usable model. So I actually don't really completely understand the data engineering term and such, because I was a product engineer, maybe, in this traditional sense. And we were trying to solve the product problem, is get the ETA out. And so we had data. So we took data, modified it, churned it. We had a couple of data scientists work together with them, got models, and put them out into production. And this happened like constantly, right? And that's how we started. But what we realized is there are some people who knew certain things better. Like, definitely we had some data scientists who knew XGBoost way better than me, and they loved working on that, right? And there were some people who knew Spark really much better than me, for example, right? And so we wanted to get all of these people together to work on unified problem. And the problem was, let's get ETA the best ETA that we can do. And so that's how I saw data engineers and data scientists and product engineers working together. Later on, we did get more data engineers and data scientists in the company, and we tried to actually centralize all the data engineers in the company. We also had a data science function that was more distributed. We also had a centralized data science function. Some things worked, some things didn't. I actually think because the fast-moving nature of machine learning models and the products that are evolving today, we need to push data engineers to the periphery, essentially towards the closer to the products themselves, because they need to evolve and change everything. If you wait on a central team to actually change everything, it takes a while. And that's where, instead of centralizing the entire function, you want to centralize the infrastructure, which allows you to self-serve and bring people on very quickly and let every team hold their own destiny and move it faster, right? And these are the ethos of Flyte, right? We built it in this way so that it's kind of a self-serve platform. It's a centralized platform so that there is one dedicated team that understands, like we were just talking, Kubernetes. We don't want everybody to understand Kubernetes, but we do want the product teams to understand their destiny and have it in their hands, so that they can iterate and move faster. But so Lyft has been going through multiple these journeys, but I think they are moving more towards decentralized model now.
Yeah, and two quick points in that, Ketan. I love the explanation of ETA, because I'll do a dig at Uber and leave Lyft out of it, but I'm always looking at my Uber phone and going like, I think Uber's got some time dilation going on, because that 3 minutes is still 3 minutes. Next time I'll go to Lyft support and say, what's wrong with your ETA model? What are you guys doing with the ETA model? So I can give them a dig on that.
I'll be spinning the beans here, but 3 minutes is a magic number.
Yeah. Say no more.
Yeah, 3 minutes is a magic number.
The fairy dust is off today and stuff like that. But but the second point is like, even though we're ODSC, we're on a data science conference and all that stuff, but that's definitely been my if you look at the work that data scientists, but especially machine learning engineers do, in my opinion, you're data engineering team should be bigger than your data science or machine learning engineering team, for sure.
Yeah, I think that is the case.
Given the importance of the data plane versus everything else,
But I think my take over there is almost every product engineer was a data engineer. Because
Exactly.
That's how. Again, that's why I'm saying that the qualification of what a data engineer is. Like there are are they just doing ETLs? I don't think so. They are doing more than ETLs. They are actually getting features, get models, helping models go to production and so on. And I think that blur distinct between that, there's a SWE and there's a data engineer. I think that's shifting. I think they are coming together. And then, of course, there will be some specialization that people will have, but they need to work together.
Yeah, fair point. Yeah.
Very fantastic. Okay. Also wanted to quickly touch on what was your inspiration for Flyte project at Lyft, and can you tell us more about it?
Yeah, and the story is very simple. It's like no inspiration. It was essentially solve my problems. I was responsible for that number, as she was said. I had to get it running. I didn't want to build. Like I actually had done a lot of infrastructure in my career, as we talked about my career, and I didn't want to do infrastructure. I was like, I want to solve problems, and I was like, I'm not going to do infrastructure. I looked at the problem, and I was like, okay, workflows, and we need a workflow because there were humans like running things one after the other, and we're like, no, this is a solved problem. We understand how to run things one after the other. So we're going to find something that exists. And we did find something. We found Airflow, for example. But it didn't do what we exactly wanted. We wanted data to flow within the steps. It's crucial, right? Like we wanted multiple experiments to run at the same time. We wanted A/B testing, and like lots of those things had to happen together. And so we tried Airflow. We hacked it up. We like completely pushed it to its limits. And we, with blood, sweat, and tears, we actually launched our first model through Airflow. But as it is, we launched one, and then other people within the company started saying, "Hey, what did you do? I want to do that too. We want to launch a model in the same way." And we're like, "Oh, hold on, this is not a platform. This is me over a weekend hacking things up and getting things running." And so that. And I was like, let's take a step back and just write down what it means and what is it that people want. And we wrote a 15-page paper, essentially internally, that talked about like what could the platform be. And it was not with an intention of building it first. It was just trying to answer the question of what.
Questions. Right.
Right. And then that led to people saying, oh, you can't build this. This is just not buildable. And then that becomes a challenge for an engineer. And so I somehow got a month from my regular work, and I got another engineer. Two of us got together, and maybe we got one more person here, and then that's the POC of Flyte, and that got two teams just out of the gate. They had not been able to deliver models for a bit. They were able to just deliver with it, and that it is, and that delivered models. Got spread out, the word spread, and so more people started using Flyte, and that's how Flyte started. Really, it was not meant to be open source or anything. It was just solving my problems, really, to be honest.
And that's great. And I'm a big fan of Airflow as well, but you'll probably talk more about it later. But I do see in Flyte that tasks are like first-class citizens in that ecosystem. So there's definitely a need for something beyond Airflow. I'd love to get into that in more detail.
But all kudos to Airflow again. Nothing against the community, because I think it assured that direction within the open source ecosystem. But it's also been like 8 years or something, right? Like things have changed. Like it doesn't have the architecture for the evolution that needs to happen, and that's where Flyte was born. It does borrow a lot of ideas from Airflow, but it kind of builds on top of them and makes them broader.
Do you mind giving us a quick high-level overview of the architecture of Flyte? Because I assume you're using its microservices, RPC, all that good stuff.
Oh, yeah. So some of them were just with goals that we wanted to start. Like one of them was, is what we realized is like we wanted it to be self-serve. So people come in, teams come in, they kind of build their own isolated space and they work on it. Second thing we wanted was it should be serverless for the teams, because most of the time we spent was essentially like, getting machines together to run one type of like flow, or sometimes scaling it up, and like DIY in there, and it just doesn't, like, there'll be problems. You never built it
Right.
for a specific thing, then another request comes in and, oh my god, now I have to redo all of this, and that took like months, right? So we wanted that. We actually had an anecdote where one of our team members left the team, and with him we lost the model that he had built, which was in production. And we were like, okay, let's rebuild this model. And to rebuild the model, it was in his Jupyter notebooks or whatever. We had some semblance, but not the exact version that was delivered to production. So we were like, okay, it should. We know the algorithm, we know everything, so let's just build it. We couldn't get to the same level of accuracy for like a couple months of trying it out, and that's another thing that we realized, nope, this cannot happen again. We cannot. We have to be reproducible. That's where that leads into, if something was done once, why can't we redo it? And that is huge tech debt. That, because this is lost engineering effort, and it just doesn't scale as the companies grow and people leave, right? You want that freedom that people can move jobs. So that was important. We also wanted to get into a habit of people pushing their code into, because of this same reason, into a stable repository of some sort. So that's where like the Docker containers and strict building happens. So what Flyte does is it actually captures the essence of your code, converts it to a specification. So Flyte started with a specification. There is purely a specification. What you see today is one implementation of Flyte. You can have multiple implementations of it eventually, and it's like having the JVM's language spec and having multiple languages on top of it, OpenJDK and so on, right? And so it's a very purist in that way. And then so once you extract the code information from it and you upload it into the server can now execute your code any point in time, because it also uses Docker containers underneath to transport your code over. And what that gives us is like two people working on the same piece of code, but maybe they use like, PyTorch version, or TensorFlow is a great example. TensorFlow version 2 and TensorFlow version circa 1, completely different, use different environments. They can operate at the same time on the same piece of software. So those are the things that we started with, and we wanted it to scale to anybody and be extremely reliable so that people can run production workloads on it. So these were the design constraints on Flyte.
No, and that's awesome, because a lot of attention on workflows and pipelines over the last couple of years, and that's great for getting into production quickly and all that stuff. But reproducibility is it's on in certain domains like healthcare, pharma, finance. Reproducibility is a requirement of any workflow and process you put into a production environment. So I definitely see that's going to become more and more important. So kudos to you guys for engineering this in at the start. That's pretty cool.
Yeah. Like another concept that we've actually started, I would say, is memoization. Again, we had a conversation about this. Memoization essentially means when something's done, just don't redo it.
Exactly.
And so, but for that, we had to actually engineer quite a few things to do it correctly. Like we had to understand what types of data are flowing through, so that we can actually create a correct signature of something that has happened in the past and then redo it. And the way we wanted to do it is that anybody in the company, let's say, runs a query that extracts all the writes for the last 24 hours. Nobody in the company ever needs to rerun that query again. They can just reuse the results. And so we wanted to build it that way, a different way of memoization, a global, like distributed memoization. Yeah. And that's what Flyte supports today already. And so we kickstarted that. For that, we had to build the type system, and we had to understand a lot of the isolations within the code boundary. But
yeah, and given the cost of running these models and all that stuff, that's
extremely.
Yeah.
Yep.
If your boss is yelling at you for your cloud bill, that's key.
Oh yeah, like I think for companies like Lyft and Uber, right, cost is extremely crucial, because they are
true.
They are a layer on top. So.
Exactly.
Makes sense. Okay, Ketan, just one quick question around Flyte itself. How do you think it is changing the face of machine learning and data workflows? How would you say
Uh,
that?
yeah, I think one thing we'll say, and it's not only Flyte. I guess there were a few other products which happened in the
Yeah,
last couple of years. Flyte started in 2017, but it was indoors, right? Nobody knew about it.
exactly.
What some of these folks have realized, and many folks are bringing to the table, is data, like understanding that, like in a data flow system, understand the flow of the data itself. So understand the data, right? That's
Hmm.
important. It's getting the parameterization, executing with parameters and so on. Number two, don't treat time as something special, because time is, like in machine learning, time is really completely malleable. It's just a parameter. And I'll give an example. So when you're training a
Yep.
model, you actually train it as if it's the past, right? So, and then you may change the past. You may say like last 1 month, last 1 week, last 3 months, last 1 year. So time is malleable. And so time needs to be a very uh, like not a special parameter, but like just a regular parameter. Like you can say numbers between 1 and 100. Same thing, time between yesterday and today.
Hmm.
Uh, Another thing is, so that's the most important, I think, that many other people have got on. But from Airflow, we borrowed. And Airflow had this interesting concept of, actually, it was the beginnings of serverless in data. It's kind of
Yeah,
weird to say that, but that's what it was. It just did not know that it was doing this, right? Like, so it was not purpose designed to be serverless.
the hidden
Flyte, we
feature.
actually, yeah.
Yeah.
So Flyte, we purpose designed for being serverless. We realized that, oh, that's what people actually end up using Airflow for. They start writing code that actually runs on the server and Airflow breaks, right? And we actually were like, oh, what is the thing that people are writing? People are writing TensorFlow code that needs GPU, but sometimes they're writing CPU code, and you need to pick your resources. So you need to like actually change resources based on your task that you're working on. And then we wanted to actually, another thing was Airflow. Like in machine learning, things happen ad hoc.
Hmm.
You always ask for a model to be trained. You don't like just say like, okay, you don't on day one start like, let's start training for the last 15 days. It doesn't work, right? You first train, then that doesn't work usually. And you don't even do training of a model. You first go to the data and you're like, this data looks okay. Then you kind of go and extract features from it. Usually they don't work on the first attempt. So then you go again and modify certain things and probably clean it further, and that's when you probably get your
Hmm.
real features that you're going to use for training. Then you go to your model and you use those features, and you try one model, you try some different hyperparameters, you try another model, and then finally, once that model, you actually need to do validations and make sure things are correct.
Exactly.
So this is the process that we wanted to smoothen, because also when you're extracting features and training a model, there's scale involved. You can't do it on your laptop. I know we all love to say that we want to run everything on our laptop. Yes, a small subset works, but when you
Hmm.
have terabyte of data, you want your model to run on that terabyte of data. What's the
Very
use
true.
of having a terabyte of data and not using it to train the model? Of course, having good terabyte of data labeled with ground truths, amazing, right? It's treasure chest. So, but
Yes.
that doesn't run on your local laptop. So you need the scale from your laptop to the cloud immediately. And so that's the thing that we wanted to solve. And that's why we have like an API. Everything is API driven. If you can do with the console or any of the Flyte tools, you can actually go ahead and write your own UI on top of it that does those
Nice.
things. So people can drag, drop, and build workflows. You can do all kinds of things with Flyte, which you have not even explored in the open source.
Wow.
Cool.
Yeah.
Interesting. There's a quick question from the audience. Let's pick this up from Christine. Hi, Christine. Thanks for the question. Are you saying the time is a parameter that can be adjusted to help the machine create a model?
Yes, absolutely. I think usually, if you ask any machine learning engineer, they are implicitly doing it, even if they are not
Hmm.
explicitly doing it. They are getting data as of, right? And they are
Hmm.
getting data from some point, assuming your time variant data. There are cases when data is not time variant. There are some ground truths, but otherwise, like satellite imagery, changes every day, right? It's changing constantly. You just don't have mapping data. It's changing all the time, even though the reality doesn't change, but it's changing also. The reality cost actually also changing all the time. Like you get a digging on the road on some side, something. So time is a parameter. It needs to be treated as like one. And yes, Flyte allows that. But yes, when you train it regularly, then time becomes a special parameter because time is implicitly input from the scheduler. And so, Flyte allows you to do that where you actually say, oh, I'm passing it today because I know, but now I'm going to run this on a schedule. Just derive it from the schedule. And so this direct flow from writing code, using the time and then converting it to an implicit parameter is another thing that actually Flyte does pretty well.
Super interesting, Ketan. There was another follow-up question from Christine. Is adjusting the time similar applying statistical analysis to historical data?
Is adjusting the time similar to applying statistical analysis to historical data?
So time series.
I'm probably going to try and understand the question. I'm so sorry if I don't, if I answer it wrongly. But analysis are performed as an output on the data, right? Time is probably the input that selects the data. I'm more talking from a selection point of view. Hopefully that.
Yeah, that should answer for Christine, definitely. Okay, moving on, shifting gears a bit towards one of the most important topics today, which is MLOps. And I know for a fact ODSC has featured this topic for the last couple of years, and now it's so hot. So, Ketan, why do you think, like, what's your first thought? Why is it suddenly that everyone's talking about MLOps? What are your thoughts around it?
Yeah, I think the word was coined recently. We didn't land up on. I never started the business now or the product saying that this is solving MLOps or something. But I think it does fit the paradigm, or at least I'm trying to understand how to really define MLOps, right? The way I've started thinking about it is that 10 years ago, we said DevOps. People didn't really know what DevOps meant. Like
Exactly.
But it was a term that was coined. And then now if you say DevOps, like people know what it means.
Exactly.
I think we are in the phase of like the 10 years ago DevOps where we're still like kind of like defining MLOps. And it was required because we, in software, we want to deliver our software to production. And that when it's in production, there are operations with it, but to delivery also needs a lot of operations, right? And that's DevOps. And with MLOps, the same thing. How do I operationalize the process of taking something, ideating over something, converting that into a usable outcome, and then delivering it to production seamlessly? And it's a huge topic, I think. Like by the breadth of it, it's like a large coverage. Flyte is like solving one piece of that puzzle. I think MLOps, we need to still work on it further to make it cleaner, but it does refer to the process of like making sure we can actually take whatever we are thinking of and deliver it to production. That's the end goal. If we don't do that, then that's like we are probably lost somewhere in between.
No, and I think that's great insight, Ketan, because people, throw around the term MLOps, which is essentially data engineering, like it's a solved problem, but it's a big tent, as you said, it's a huge tent. And we're already trying to solve reproducibility, reliability, scalability, all the abilities that people are looking for. They want continuous integration, continuous deployment, continuous testing, continuous monitoring. And that's going to be a moving target for a long time, because pretty much everything gets thrown under the MLOps bucket. And I can definitely see a further differentiation between pure learning operations versus data engineering. So at what point are you working on the data plane? So it's too big. It's almost too big a field to have expected. I'm an MLOps engineer. Like, I'll bow down to you if you say you're an MLOps engineer, because that's.
Yeah, like there's some parts you have to understand GPUs. You have to understand how to train a model on GPUs, like the CUDA stuff that I was doing like 10 years ago, 15 years ago now. Two, you have to understand like data pieces, distributed systems. You have to understand. Now you throw in Kubernetes in there. You throw Docker. You're like
So it'd be kind of like saying,
it's crazy.
In the software world, I'm a software engineer, front-end engineer, back-end engineer, data engineer, software architect, data architect, and a DevOps person all rolled into one. So I'd be careful about putting MLOps engineer on your resume. But if you're looking for a career,
I don't write it. Neither do I say data engineer. Neither do I say dev. I just say an engineer because that's what I am. You shift, you shape shifter whenever you want. We are all shape shifters.
100%, yeah. But I think to your question rather than to your answer, that's why it's so hot, because it's just such a big tent phrase.
Yes.
Yeah,
definitely.
and I think you need a way to define, right? Some way, because we know that these things are important. We just don't know what tent do they fall under. So we need like a way to put things under, and that's what we are using MLOps for. And I think if I had an opinion in 10 years, we will absolutely define the right chambers within that tent, or at least define it clearly.
Very good point. Yeah.
But it'll take 10 years, maybe.
Fantastic, Ketan. Definitely looking forward to see where we are with MLOps in the next 10 years. But moving on, obviously many of us here are familiar with dynamic and static typing in software engineering. And that's one of the discussions we had yesterday as well. But for our audience, definitely, you mentioned static typing, type checking in data systems. Tell us more about it.
Yeah, this is something that actually Abe Gong from Superconductive, which they are doing Great Expectations, fantastic work. Him and I have been having some chats on this as well, where we are thinking, like currently, we like partially because of Airflow in some sense, right? We just execute some tasks one after the other, and the data flow is handled outside of Airflow, and so people kind of like move things around. And from an outsider's perspective, there is no understanding of what's happening in that system. It's kind of like opaque, right? If I look at a pipeline, yes, I know that it's processing something, but I don't know what's flowing through it. Like you cannot introspect at any point in time and see. So that leads to the question that we need to understand data. But what does understanding data really mean? Does it mean understanding the actual values? Potentially not, because there could be terabytes of data. You cannot really understand everything. So what you want to understand is the essence of what that data is. Now, and in software engineering, we have a term for this. We call them types, right? An integer, when I say integer, immediately your brain goes and says like, is it 32-bit or 64 bits? If it's 32 bits, it's 0 to 65,000, right? Whatever. That's because we've been taught this stuff, right? And so when you start understanding data by this lens, then you have to have a type system that actually defines what data is flying through. And actually, let's take an example of Python. Like Python is a fantastic language. It started off being completely duck typed or dynamically typed, and now more and more emphasis on types within Python, and it's actually blowing up. And the reason is it makes it more readable. It makes it more self-documenting. It makes it easier to use, and there are other benefits that compile time performance, right? So, for example, the other thing that happens in data systems, you have like these large, gigantic pipelines. I've seen pipelines with 1 million steps at times. They're not handwritten; they're constructed. But you don't want it to fail at the 100th step, for example. And a pipeline when you run, it's really painful. So, and usually if you write the software correctly, you unit test it well, and then you just integrate it. From software engineering, we like that it works together, right? Of course, you have to do integration testing. There's no way out of it, but it does give you some guarantees. And for that, you need one, static typing, and you need a compilation that actually compares the types and makes sure that things actually connect the way they should. And this actually prevents the problem of seeing the 100th step, which could be 10 hours later, to within 10 seconds. You immediately see that, I was this thing expected a table of 4 columns and I'm passing it 5 columns. Not going to work. That pandas data frame is going to cry. And that helps a lot ahead of time. And that's, I think, what I mean by static type checking. You can actually come up with a set of types that define what, like this fantastic work done by Wes on Arrow. And there's another amazing set of work being done by Great Expectations of Quality. We can put like this sort of work together into a common type system, along with other regular types like primitive, string, Flyte, and make a compelling type system that actually allows you to statically type check a workflow or a pipeline before you even run it. Yeah, you'll have runtime errors because you took an integer and you're using it like a string. There's no way our Python doesn't do that sort of checking. But it's still fantastic, right? Like it's like so many class of errors are just gone. And that's why the proponent of typing within data systems.
Very interesting and great points around static typing, Ketan. So just wanted to know how Flyte implements static typing. How are you doing that?
Yeah. So as I said, Flyte is a specification-driven system. So we actually have a specification. It's done in protobuf. So you have protobufs in which you actually model all types of types that are flowing through the system. Actually, interestingly, Apache Beam is doing something similar. When we were looking at, like, just recently found that out. So you have a protobuf specification in which the user declares the intent. So if you write any Flyte code, you can write it in any language. Currently, we support Python, Java, and Scala as 3 languages to write a Flyte code. Python being, the most popular one. So when you write in Python, you don't just write Python code. You have to use type hints. The moment you use type hints, our SDK analyzes that and converts it to the protobuf representation of those types. And then takes the function and also converts it to a protobuf representation. What that means is, here's the Docker image, here's the function that I want to run in this Docker image. Here are the inputs it takes, and here are the outputs it produces. And the inputs are like integer, string, table, or pandas data frame, all of that stuff. And then we post that into the hosted system. And then you do that for multiple tasks. And the hosted system can now say, oh, when I put them together in a workflow, this is not going to work because you're creating a table, as I said. And that's the distributed compiler that comes with Flyte. So this is how Flyte implements the type system, completely in a specification-based language in protobuf. It's open source; people can see it.
Yeah, I would just encourage, like, that's a huge development, because I would encourage anyone on this webinar or live stream to actually look into static type checking for data pipelines, because it is, as you guys mentioned, is a huge topic right now. And catching errors early is always a huge deal, and definitely early in machine learning and data science, this wasn't a thing, and it causes huge problems. That's awesome that you guys have done that.
It's actually catching a lot, even in traditional software, like C, C++, all type safe languages. But like, for example, Rust, we were just talking about this yesterday. Rust has formally verifiable types that actually can find if there are concurrency bugs in your code, right? It's just amazing stuff, right? Like, this is how we push the envelope on our systems. And that's why I think we'll need this, like, just to make it much better.
Absolutely, yeah. It's definitely a requirement of systems like these, for sure.
Awesome. Super interesting. Thanks, Ketan, for that amazing explanation there. So just wanted to move a bit and ask you what, according to you, is like an ideal workflow for data science organization. How would you mention that?
Oh, I think maybe rather than ideal organization structure first, probably, in my opinion, completely my opinion, is that I think that data science, data organizations need to be together for sure under one umbrella, because they kind of, when I say data science, data organizations, I mean the infrastructure part of that organization needs to be together, because they're very, very relevant and kind of together. They absolutely need to support self-serve, where teams should be able to move independently without really needing to constantly, deploy to one central place and like break everybody else. That doesn't work. You need to be isolated per team, and each team needs to move independently and at the speed that they want. Some teams
True.
move slower, some teams move faster. And that will always be the case. Uh, there, there needs to be data product engineers that needs to
Mm-hmm.
sit with the team to actually help them build and understand the data and clean it up correctly, because it's again self-serve to the periphery. But we have seen, actually, that a centralized AI function with some experts, because it's very hard to hire this super awesome AI expert. Like they're all the big companies have hired all of them. So a centralized function of having a few AI experts that actually kind of work uh, like teams that come in, like get dropped, like the special ops that comes in, works with
Mm-hmm.
your team, helps your team's data scientists or data engineers and SWEs and so on to build their models, and then leave and they go and help. It actually kind of works. It's a faster moving, potentially a faster moving system for most companies. So that's my small take on this. I don't know if that
Yeah.
answers your question, but
No, that's definitely something which is very much interesting, and I'm sure audience might be curious to hear, because this is a perspective coming from a person who's just starting up his company, and that brings me to an important topic, which is about your startup. So can you tell us more about it and to our audience?
we are stealth. The name of the company is Union.ai. There's not really much to tell. The story is very clear, where we are the guys that want to make Flyte work for most users. You definitely jump into our, go to flyte.org and jump
Mm-hmm.
into the Slack channel. You'll see folks from my team helping anybody and everybody without really, there is no agenda in there. It's weird to say this, to get people, understanding, because we think we are trying to, deliver a strong punch.
Right.
It's hard to take that punch, right? It's like, oh yeah, this punch, containers, serverless, Kubernetes. Oh my God. So you
Yeah.
need somebody to help you around that way, and think of us as your, extended team that will come and help you. And that's Union.ai. Yes, there is a commercial aspect eventually, which we will unveil sometime soon. But I can tell you in short is that it's Flyte plus plus, right? That's literally what we're going to do. We will be building on type of Flyte. We absolutely want to build a fantastic open source product. And the way I've been saying this is that we are trying to build a Mercedes in open source. We are a full featured everything all together in open source, because I think people deserve that. And big companies will use it the way it is. Smaller companies may need help with, like, they're operationalizing it and making sure, and that's where we come in. We want to help them
Amazing.
get whatever the big company get, like basically create a level playing field across everybody.
Awesome. Can't wait to see what's next for Flight, and it will definitely take off. So
Thank
looking
you.
forward to it, Ketan. And just for our audience, one last question that I had for is, I know you're doing a half day training at the West Conference. So can you tell us more about it? What you'll be teaching? And you'll be doing it in person, so folks can learn more about it. So just tell us
Yeah.
more.
So
Yeah.
Yeah, so what we are going to do is, of course, give a quick overview of the like why we did this. Like, some parts of today will be distilled into the thing. Jump into
Mm-hmm.
Flyte, like talk about concepts, and then look at some examples and people who have been successful doing what, and then actually do a hands-on training on writing your first set of workflows and first set of pipelines, and and then actually the most important part, like we found for most organizations, because we think we are building a platform for other platform builders to build on top of. So how to extend and adapt it to your own needs within your organization. So we will be going through covering these three topics in that order, and Q&A, and we definitely want to answer. We don't think we have done a great job in marketing Flight, so this would be an opportunity for us to do slightly better.
Fantastic. Can't wait. And just for our audience, definitely, before we make a move to our Friday schedules, This is where you can actually have a look at our West conference. Ira has been kind to share the complete schedule, so you can have a look at it. And we will be in person and virtual. It's a hybrid conference from 15th to 16th November. So feel free to join us, and definitely looking forward to it. But Ketan, this was fantastic. Thanks for all the insights that you have shared today. It is definitely very useful for us, for our audience, and can't wait to see what's next for you.
And Keaton, yeah, I'll second what Ravis says. You are definitely a data engineering rock star. And can people follow you on Twitter? Like, where can people follow what you and your team is doing? Like GitHub, obviously. Get on there.
I think LinkedIn is better for me at the moment. That's something that I'm learning a little bit more. I'm not a great social media or a person who posts a lot, but on LinkedIn I'm being more active. So LinkedIn is better. I'm Twitter.
Yeah, that's great. Yeah, and thanks so much. And again, if people can check out your training, that'd be awesome. But also, you just published a blog on opendatascience.com, so check that out as well. And and most importantly, like a huge thank you from the open source community to building something like Flyte. It's very timely.
Very true.
It's an awesome tool, awesome platform, and
thank you.
Like myself, I'm a taker. You guys are the ones who are giving out this open source. So again, and huge thanks for building that to you and the team at Lyft, and then you continue off on that. So that's that's great that you guys are so open source community focused. That's fantastic.
Yeah, thank you. We believe in customer obsession. That's one thing I learned at my Amazon days, and you will see that we bring the customer obsession to open source. Like we basically are your Amazon for open source. So please come in and join our Slack channel, and we'd love to hear feedback. We're still a growing community, and every problem, like all the negative feedback that I hear, is always the way we improve our system. Yeah. So love it. Please, let it come my way.
And also, any way ODSC can support that community, just we're only mail away.
Oh, that's amazing. Yeah, this was fantastic. This itself is going to help us a little bit. So quite a bit, maybe. Who knows? So let's see how this goes. But we are going to come knocking, Seamus, and we are going to be like, hey, please help us.
Absolutely. 24 hours. Doors always open.
Absolutely, Seamus. Pleasure.
Awesome, guys. Thank you very much. Thanks, Seamus. Thanks, Ketan. It was fantastic. I will see you all later. And thank you, everyone, for joining us today. Have a great Friday. Bye.
Bye-bye.
Yeah, thank you.
Bye, guys.